Good morning, guys. This is Jaco. Right, so let's get started. So today we're gonna have a look at the advantages of using paperless documentation. We're gonna show some of the features, some of the um, industry needs and industry trends. As you all know, my name is Jaco, and for the next 35 minutes or so, we're gonna have a look at um, this content. So if we would look at what Wikipedia defines as what technical documentation, you will find a brief description. But in short, it's basically just taking your designs and your models and convert it into readable documentation, either via Word, PDF, videos, that my customer or my end user can understand how this thing works, how it gets assembled, how to maintain this, and how to service the product. So let's jump in. So who is the technical stakeholders in my company? Um, some guys would say it's the engineers, some guys say it's the technical documentation sits with publishing, sits with marketing or manufacturer. But from my point of view, I feel that everybody in a company has some contribution to my technical documentation, and I'll explain to you why in a few minutes. Let's look at the type of technical documentation that we need to create and we need to deliver. So as a few examples, we sometimes need assembly instructions for the guys on the shop floor. If I need to assemble stuff and I don't want to create the documentation for that. Marketing materials for my customers, owner manuals for the guy who buys my end products, maintenance and repair manuals for the guys that need to do the services and to maintain the product, sales tools, and obviously training materials and part catalogs. So why is this content so important? Why do we need technical documentation? Why do we need to create stuff like this? We all know the old saying that a picture is worth more than 1,000 words. So sometimes I always say the mind works like a parachute. It works better when it's opened. It's like that. This is how it works moment. Imagine a simple picture like this, um, just to explain how that cap screw would fit onto that cap end. It would take 1,000 words just to explain that. Videos is always easier for us to comprehend than pictures, and slideshows, animations. It helps the guys that needs to do this, needs to do assemblies, needs to do the training. It's a lot easier to work with than encompassing documentation, and I'll explain to you why. But in my company, where does the content start? Where does this technical documentation needs to be created? Is it marketing? Is it manufacturing? Is it the assembly guys? And we would all agree most of these documentation either comes from the sales and marketing team or the guys that do the quotations. My training guys need technical documentation. And sometimes in the technical department, this is where most of the documentation gets created. But how does it affect different stakeholders in my company? Let's take management as an example. All that management cares about is how quickly my product can get to the market, how competitive am I in that market, and what is the quality of the content I produce. If I look at an engineer's point of view, he doesn't really care about um, how the documentation looks. He just wants to be very productive. He wants the product out of the door as soon as possible, and he wants to be able to communicate complex information to non-engineers. So the guys who don't have a technical background needs to understand what this engineer wants to say and how does he want to communicate it to that stakeholder. The guys who do the manufacturing or assembly, the guys on the shop floor, for example, um, he doesn't know how it needs to work. He just needs an instruction documentation or a video or assembly instructions. How do I need to assemble this so I can ship this out to the customers? Ladies or gentlemen in the documentation department, these guys is not always technical orientated. They don't have the technical background, but they are very good in creating content. But we need to bridge that gap from technical knowledge to creating this technical documentation without breaking that communication chain. And this is very, very important for the stakeholders. The sales and marketing team, what do I need from my technical team? I need pretty documentation. I need pretty pictures that I can present to my customer that's appealing to them. I want to be able to sell something to a guy that looks and feels great. And this is the need for the sales and marketing team. My training staff, my lady in the training room, she needs an instruction manual or a training manual that she can go step by step to explain to the user or the trainee how does this product work, where does it fit, and she needs like a step by step instruction. So as you can see, everyone in a company needs technical documentation, but always at a different level. Everybody's got his own um, level of expertise that he can bring to this. But how do we, or you as a company, generate technical content today? So let's think about this for a while. Who does your technical documentation in your company? Is it the design engineers? Is it the guys on the shop floor? Do you have a dedicated person appointed just for your technical documentation? Maybe a lady in the background that gets all the info from engineering and marketing, and she has to compile everything, um, struggling to get info from these guys. Or is there a total new department, a separate department that gets fed all the info and then needs to create the documentation for us? Another few questions. When creating these technical documentation then, when do we do this? The ideal situation or what we want to achieve is during the design. As soon as the design starts, I want to start with my technical documentation. But in our minds, we think, oh, we'll just do it once the product is finished, once the design has been done and the final product has been approved, then we'll do the designs, right? But in reality, this only gets done after the product has been assembled or after the product has reached its customer. Then these documents gets created. That's 90% of the technical documentation that's created only gets done right at the end of the life cycle of my product. And then we struggle with, okay, right now, how accurate is my actual content? Is the images and my product actually the same? Is my end product, does my end product match what I've sold to the customer in my marketing and my sales presentation? And if something needs to change, how quickly can I change this downstream and down the line for my end product? So from my side, I have a few conclusions. Typically, the technical documentation gets done by designers, which it's a huge resources that we used for our technical documentation at this stage. In an ideal life, we actually want a serial process. We want as soon as possible to start off the technical documentation. So as soon as my modelers and designers start modeling and building my product, I want my technical documentation to start as well. By doing so, I want to utilize my design engineer's time more efficiently with designing and engineering new products or advanced on my existing products instead of doing technical documentation. As we know, technical documentation is very time consuming, and hence my discussions regarding the technical documentation software. But sometimes the data we generate is not accurate, and it's not aligned to what have been designed and engineered, and we have to realign and change that. But we also have to know that we have a time to market that we need to fulfill. The quicker we get our new product out of the door, the better we compete with our competitors, and the biggest advantage we have. But the biggest point is customer experience. How does the customer feel? The end product I supply to my customer, how does he adopt to what I have given to him, and what is his experience when from the moment I sold him the product till he have the end product in his hand? And for that, we need to run a lean process to reduce the cost and have a quicker time to market. But nowadays, currently, majority of the guys, we use paper to do our technical documentation, which is a costly and a tedious process. Just think about a few bullet points. What does the use of paper have on our environment? Storing these documentations, let's say 10 years worth of production documentation. Where do I store these documents and papers? And what happens if the engineer decides 2 years down the line, we have to change the design because in the field this specific link has continually failed, so we need to change design. Then we have to go back and find all that documentation and update that manually. So this is where then paperless documentation would come in. So a few examples of where paperless documentation is very successful is with especially on the shop floor animation and assembly instructions, playing a video showing these guys how this stuff gets assembled, how to manipulate all these parts, services and maintenance manuals. So if I buy something and I want to do a field service, I should be able to send my technician, and he should be able to perform a field service on that. So let's take a few examples on these type of documentations. So we all have seen these type of user manuals. When I buy something from Macro or from Dion, I get a user manual like this shipped with my product. Yes, just a few examples. Something simple like buying a hairdryer, the pros and cons of using it, instructions, do's and don'ts. We all know how these instructions look like. What about assembly instructions? If I buy a new product, everything is not assembled because of packaging and shipping costs. So if I buy something, I have to assemble it myself. So these instructions is typically the type of instructions that we will receive when we buy and get these products. Maintenance, if I have bought a machine that do specific work, I need to loop specific areas, I need to maintain specific areas. It will explain to me then something similar to this. What my favorite one is, what about this one? Imagine giving a document like this to a non-technical guy or somebody who just joined the company. We all seen that guy that takes instruction manuals and turn it upside down. This is what we want to avoid. Podcat logs. We can go on this. This is typically in the industry. See how clear this one is. For example, parts brochures. So what is wrong with those pictures I showed you just now? There's a few points. It's confusing, it's complicated, too much detail at once. But for me, there's three major things. The content is not user friendly. It's difficult to see, it's difficult to use. The hindsight of it, this technical documentation only gets started at the end of development progress. So once everything has been done, then the documentation has been created. And what about rework? Something changes now. Um, I need to change something in the design. What is my impact on that rework, and how long will it take to be up and running again if my design changes then? So if we look at the traditional technical documentation process, pretty much what will happen is we would design or model something, um, start off with my CAD product. I would manually take screenshots, capture using different screen capture formats, doesn't really matter. I would then have to modify my image so it fits into my flow of workflows. I would publish them then out, and then I can actually have a final product, a PDF, which is almost never live. So it's, as you can see, it's a really manual and tedious process. But what happens, in my previous comment, what happens if something needs to change? Then step 2 to 5 was irrelevant. I need to do it all over again. This is where SolidWorks have a product, SolidWorks Composer. So SolidWorks Composer gives us the power to do these type of technical documentations, but digitally, using different types of formats. I can have videos, I can have assembly instructions, I can have whatever. I'll show you a few examples in a minute. Taking away the tedious process and taking away the paper process, bringing it into the software environment. So what is the benefits of using a product like SolidWorks Composer? It's a lean parallel process. So what it means is my technical documentation staff can start utilizing this as soon as my design starts. As soon as my modeling starts, my technical documentation can start at a very early stage. I can improve my quality of my technical documentation because the creator have more time now to spend on creating high quality images and videos for my clients. Everything is in real time. As soon as the design and the model changes, updates, my technical documentations will update accordingly. And a few another examples, just creating customer experience, deliver my project on time. Again, we know that the technical documentation can put a big halter on our experience and getting our time to market. And obviously, the cost of the implementation of this, the cost reduces dramatically because of we can work now parallel with my design team. As soon as they start, I can start my technical documentation. Just a simple workflow process to explain to you and to show you how this would work. So I would just open up my product, bring in my part, I would create my images, I would add my annotations over there, I would capture the different views, I would generate my images or AVIs, and I would publish it out in a few simple steps. And if anything changes in the beginning at my design phase, this whole process would update automatically. So here's a few examples of what SolidWorks Composer can do. Just to name a few, what stands out for me is the assembly instructions. As I mentioned a few times, services procedures, maintenance manuals, instruction manuals when I have to, especially when I have a new product. Design animations, which is huge. I know of a customer that played this loop in his in his entrance where the customers comes in for his new product. So the customer already have a visualized experience of the product he's going to buy before he even spoke to some client or some sales guys or technical guys. So as you walk in, you can see, wow, this is how the product works. This is how it interacts in the environments. This is how the look and the feel will be on this product. So I want to show you guys a video that my colleague has sent me, how this product actually work. So let's have a quick demo of how this product will work.
File tab, open, and then navigating to our relevant assembly. Click open, and watch as your assembly is converted into a Composer file. Now, we can see the full assembly in what is referred to as the viewport. If we move our cursor over particular pieces, you can see they're highlighted in green. With a left click, we can select a piece, and with a click in the background, we can deselect it. We can do the same thing in the Assemblies tab in the left pane. Left click a piece to select it, and click the background to deselect. These sub-assemblies are also part of our top-level file. We can look inside them by clicking on this arrow, then select their pieces in the same way as the others. We can also select multiple pieces at the same time, using the Control and Shift keys. Zoom by scrolling the mouse wheel. We can rotate by holding it down and moving the mouse, and we can pan by holding Control and the center mouse button, then moving the mouse. If you ever want to return your piece into a more convenient position, click Home, go to Align Camera, and pick any of these default positions. I click the Create Camera View button, rename it, and call it Camera Default. Then let's create a standard view. Let's just name this one Default. Now let's say we're moving our piece around and that we select some parts. These parts are getting moved around. So we want to return this to the way it was. If we click the camera view and drag it in, you'll see that the camera changes, but the parts I moved are in their new position still. If we want to return them, we need to use a standard view. Same way, click, drag, and they return to their original position. Views are... So what exactly do each of these tools do? Displayed in the viewport, I have our bench grinder from last video. We're going to translate the right side of the piece. After we select it, the Translate tool will move all selected pieces in the direction we specify. So we select it, and you can see that using the axes, we can move it up and down, left and right, in and out, and by grabbing the blue sphere, we can move it around freely. Now let's just return this to its original position by pressing Ctrl Z. Put our piece to the right, the leftmost piece will remain static. So this explode view gives us a good sense of how these various smaller pieces come together to form the bench grinder. Still, this view's a little bit cluttered, with more complicated in why to use them. To start, we need to call the tool. Go into the viewport and press the spacebar to summon the digger. If the tools around it aren't being displayed, simply click the wrench icon to toggle their appearance. Let's start with the Center of Interest tool. The Center of Interest is what governs what will be displayed in the digger window. In this case, our Center of Interest is marked with a red dot on the shield assembly. By default, the digger will not have a fixed Center of Interest. It will simply display whatever lies underneath it. To set your own, click and hold the Center of Interest button, and drag it onto your new desired Center of Interest. Let's set it for the left shield assembly. Now we can start walking through the various tools of the digger. You can use the slider to adjust the intensity of the zoom. Moving up zooms in, and moving down zooms out. In general, the slider is used to change the magnitude of the effect of the selected tool. I'm going to reposition our Center of Interest to better show off the functionality of the next three tools. We'll start with the onion skin. a great way to show the internals of a given assembly. So I'll select the onion skin tool and move the slider all the way down. You'll see that when the slider is at 0%, all the pieces remain completely visible. But as we start to move the slider up, layers of the piece begin to disappear until we get a view of the internals of our assembly. The X-ray functions very similarly, but instead of pieces disappearing, they fade out to give that X-ray look. The functionality is very similar, and your choice between the two comes down to preference. This leaves the cutting plane. As you scale the slider up, this tool will begin to cut into your assembly at an angle determined by your camera orientation. As I increase the slider, you'll begin to get a sense of what this view looks like. Also important to note is that if I change my camera orientation, the cut changes correspondingly. This is the case for each of the tools we've just covered, as you can see here with our onion skin tool. But if we want the depth of our cut to remain static, how do we do it? We click the lock button at the bottom, scroll to our desired depth, and now if we move the camera, the depth remains the same while the view changes. Our desired depth. If we want to save our image, we hover over the Capture 2D Image button. If we want to see our selection in different lighting, we can click and drag the light button into the digger window. As we move it around, we can see the piece in different light. I thought the piece was good in its original lighting, so I'll drag the light outside the digger window to cancel the operation. So now let's create the image. We click the button, and our view appears as an image in the viewport, with a tail pointing to the relevant portion of the assembly. We can shrink it, move it, and save it in our view. The last important thing to mention is that even if we have created a 2D image, we can still call the digger if we find the need for additional detail. Simply get the bench grinder from the last video. I'm going to go to the Author tab and select the Label tool and label some of the pieces of this assembly. Now, with one of these labels selected, I'm going to go to the Properties tab in the left panel and change the size of the text, the shape of the text box, and the type of the attachment piece. Let's say this is how we want our label to look. We'll click this, and we'll go to the Styles tab, click Quick Style. We'll call it Quick Style number 1. Now, if we want our other labels to look exactly like this one, it's as easy as selecting them, and then selecting the Quick Style option in the Styles tab.